mic'd up?
Yeah.
Oh my god.
All right. So real quick, there's one last little concept that I want to go over for chapter 9. It's only going to take about 5-10 minutes to get it done. So you should have had that note sheet out on your desk. What we're looking at is if you're ever asked to write an electron configuration for an ion, all right, charged particle, positive or negative. So remember, when it's a positively charged ion, it's losing electrons. When it's a negatively charged ion, it's gaining electrons. So the term, or the vocabulary that this is going to deal with, and this is most likely the word that you're going to see, is if it ever asks a question, if any of the questions ever relate to something called isoelectronic. That means that it has the same electron structure as something else. So when an atom becomes an ion, it takes on the characteristics of a noble gas in regard to its electron configuration. So every ion looks like a different noble gas. All right. So what I would like for you to do, I want you to go ahead and write the regular order configuration for strontium and bromine. Don't worry about it being ions right now. Just write a neutral electron configuration for both strontium and bromine. So write an electron configuration for strontium based off of it being neutral and bromine based off of it being neutral. And then we're going to look at how it changes. So if you do the electron configurations for both of these as neutral atoms, that's what they would look like. All right, so strontium is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2. Yes?
Could you group them into Electron or something?
We're getting there.
All right.
All right. Now, if I'm changing strontium to an ion, it's going to lose 2 electrons, right? So what 2 electrons is it going to lose? The last 2, right? So it's going to get rid of 5s2. So the electron configuration for strontium plus 2 is this, all the way up to 4p6. Now, so the question would ask is what element on the periodic table is a strontium ion isoelectric 2. So looking at the electron configuration that you have now, what element would be represented by an electron configuration ending in 4p6? Krypton. So strontium ion looks like krypton. So notice if it's a positive ion, it's going to look like the noble gas on the row above it. All right. Now, looking at number 33, bromine, to become an ion, has to gain an electron because it's a -1 charge, so I'm getting an extra electron. So how will that change this electron configuration?
4p6.
It'll be 4p6. So what does bromium look like?
Krypton?
Krypton. Both of these are isoelectronic to krypton. Whenever they become ions, so in a way, when an atom becomes an ion, it's going to become a noble gas. Because remember, 8 electrons in the outer shell is stable. So the whole goal of becoming an ion is to get to 8 electrons in the outer shell. Strontium does it by getting rid of 2 electrons, and bromine does it by gaining an electron. All right, so that's really it. I don't expect them to ask this, and I know they won't ask it in active. I don't expect to see this on a test. You might see it on the practice quiz when we get to that. I just know that they've thrown that word out there before, and I just don't remember when and where I've seen them throw it out there. Now, for today, today is I'm making today kind of like a catch-up day that you can work on some stuff.